Hello, Mr. Price here, and this is the 7th question on the June 2006 Mechanics 2 paper, and this is a projectile question. Let's have a look. So we have a particle that's projected at an angle of 50 degrees above the horizontal from a certain point, which is 2 meters above ground level. And we're told that the highest point of the path of the ball is 15 meters above the ground. And we're told that air resistance may be ignored, and we want to find the speed with which the ball is projected from A. Okay, so let's model what we know. So, here's our datum position, and our ball from here is projected at a speed that we don't know, at an angle from the horizontal of 50 degrees. Okay, and then this is 2 meters above ground level. Okay, and we're told that the highest point this reaches is 13 meters above the ground. Sorry, 15 meters above the ground. Okay, which is 13 meters from datum position. Okay, so if this is the highest, if it can only reach 13 meters vertically, then we can use SUVAT to find out what speed it was travelling in, as there's gravity affecting in the vertical direction. So we want to find the initial speed. We know that it's at its highest point, its velocity will be 0, and it has travelled a distance of 13 meters. And it's probably worth noting at this point that I'm resolving upwards, and then our acceleration is therefore negative 9.8. Okay, so using v squared equals u squared plus 2ax, so v squared equals u squared plus 2ax, we have 0 equals u squared plus 2 lots of negative 9.8 lots of 13. So after some resolving, we should get that the initial speed in the vertical plane was 20.8 meters per second. But note that is the vertical speed upwards. Right, so I've done the wrong calculation on my computer. That's the final answer. Sorry guys. 2 lots of 9.8 lots of 13 square rooted so that's 15.96245 blah 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 meters per second. Okay, so we want this speed here. So we know that's 15.96245. So we want this, and we know that this angle here is 50 degrees. So using sine, you should find that u is 20.8 meters per second. And sorry about that little mistake up there. Okay, so that should be part I done. Of course, what you could have also done was say that this was u sine 50 as well. You could have also done that. Okay, so you could have also done that step as well to make this bit maybe a little bit less confusing. Up to you. Okay, part 2. Our ball hits a net at point B when it has travelled a horizontal distance of 45 metres. And we want to find the height of B above the ground. So, once it travels a distance of 45 metres, we want this point above the ground. So first we need to see how long it will take for it to travel this 45 metres in this direction. And once we've got the time, we can tell what its height is from the datum position. So let's resolve horizontally. We know that the speed is going to be 20.8 meters per second, cosine 50. And the distance is 45 meters. So time is distance over speed. And that gives us a time of 3.37. I'm going to do just a few more decimal places because we don't want to get too much lost accuracy from this. So 45 divided by 20.8 cosine 50, 6574. Okay, and then we're going to resolve upwards to find where it is from the datum position now. So resolving upwards, u equals 20.8 sine 50 v we don't care about, a equals negative 9.8, and x is what we really want to know. So using x equals ut plus half at squared, and substituting these t values in, let's see what we get. So x equals, t equals 3.36574. Okay, so I'm going to quickly put this into my calculator. So 20.8 sine 50 lots of 3.36574 plus 0.5 lots of negative 9.8 lots of 3.36574 squared. Okay, that gives us negative 1.8794 meters. Okay, so this is from its datum position, and we know that we want it from the ground position. So the whole thing's 2, take away this negative 1.8. So we should find that is 0.12 meters off the ground. Okay, and that's part 2. Okay, finally for part 3, we're being asked to find the speed of the ball immediately before it hits the net. Okay, so with this one, we're going to have something that looks like this. So it's travelling downwards, we already know this. So it'll be travelling downwards and across. So we want to know this value. And does it want the angle as well? Doesn't want the angle. So literally we just want the hypotenuse of this triangle. Now we already know that the horizontal speed is 13.37 meters per second. So now we just need to use SUVAT to find the velocity now. So u equals 20.8 sine 50. We want it at the time, just before it hits the net, so 3.36 blah 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 blah. We want the velocity, and the acceleration is negative 9.8. So using v equals u plus at, you should get a velocity of negative 17.09, which is what we're hoping it would be. It's going downwards, so 17.09, and now it's just Pythagoras. So speed squared equals 13.37 squared plus 17.09 squared. So that should give you a speed of 21.7 meters per second. And that's everything done for question 7.